Okay, so let's look at these questions you sent. There are some similar ones in the video notes, but I did notice these were definitely a little bit more challenging. And so I think, sometimes it's luck of the draw on my math lab, and sometimes you just kind of get the ones that are a little bit harder. So this first one, what you want to do is isolate the base that has the fractional exponent. So we'll add 12 to both sides. And so then let's see, we're left with this on the left side, and then on the right side we'll have 27. And then what we do is we raise both sides to the reciprocal of the fraction. So we're going to raise both sides to 4/3. And what that does is those will cancel out right there because they multiply together and cancel out, becomes 12 over 12. So we're just left with x squared minus x minus 51. And then on the other side, this is telling me to cube root, so I don't have to put the plus or minus on this one. And then it's telling me to raise it to a power of 4. And so then let's see, we're left with x squared minus x minus 51 equals the cube root of 27 is 3. So just kind of off to the side, that would be a 3 to the fourth power, which then would give us 81. And then we'll set this equal to 0 and then try to factor it. So let's see. We're left with x squared minus x minus 132. So now we're kind of playing that game, the A&M game. What multiplies to negative 132, but add to negative 1 in the middle. And you might have to play around with it a little bit, but I think it's going to be 12 and 11. The 12 is going to have to be negative so that it adds up to that negative 1 right there, and then we'll have plus 11 right there. So you can see if you were to FOIL this, you get that right there in the middle. And so let's see. So then our two solutions are 12 and negative 11, and they should both work here. I don't think either one causes an issue. And so that's our first one. Let's see. Our next one. Oh, there we go. Okay. So you might do substitution if you want to, if you look in the examples that they provide. But if you saw my lecture video, I kind of like to just, the middle guy kind of really lets you know how this guy's going to split whenever you factor. So that's kind of the way I like to do it. Nothing wrong with substitution if you want to do it. I just feel like sometimes it's an extra step that might not be necessary, but I'll leave that up to you. So, like I said, this right here kind of tells me that, oh, okay, this will be an x squared, and then now we're doing a and m again. And the numbers, once again, are kind of bigger than what we had in my note video. So let's see. I think it's, okay, so they're both going to have to be negative. I think it's a minus 9 and a minus 25. I think that looks right. So that multiplies to positive 225 and adds up to negative 34 in the middle. And then what you'll notice is we have the difference of two squares. And so we'll go ahead and factor that. So that'd be x plus 3, x minus 3, and then x plus 5, x minus 5, and then equals 0. So our solution set is negative 3, positive 3, negative 5, positive 5. And all those should be fine. They should all work. All right. Let's try another one. Okay, so this, yeah, this is a little bit more difficult than we kind of saw. And this is where I could kind of see substitution maybe helping a little bit, um, just because you're having to deal with that 8 in front right there. And so it just makes the problem really complex. And so, yeah, we can go ahead and do that. So the way substitution works is basically you're going to let x to the 1/3 equal And a lot of times we use the letter u. We're going to let it equal u. So if that's true, then that would mean, like, if you were to square both sides of this, that would mean that x to the 2/3 would be equal to u squared, right? If I were to square the 1/3, it would become, if I are, power to a power, you multiply to where it would become 2/3. And then if I square the right side, um, that become u squared. So we'd be looking at 8u squared minus 63u minus 8. And so the idea is like solve this and then substitute back in what we did for u to finish it off at the very end. And so that might make it a little bit easier. Now, it's up to you. You can do the 8 times -8, which is -64. And then we can try to split the middle. So we can go ahead and do that. This one's kind of interesting. We didn't see many like this because it needs to add to -63. So we're looking for two numbers that multiply to give us -64, but then those two numbers add to -63. And so sometimes that can really throw a student off, but it's just going to be -64 and +1. Those multiply to give us -64, and they add to give us -63. So that's what we're going to split this into. So we still have the 8u squared, and then we're going to write this as -64u. Then we'll have a plus 1u, if you want to put a 1 there. -8 equals 0. Okay, so now what we'll do is we're going to factor each one of these individually. So the first one I can factor out in 8, and that will leave me with, oh, I'm sorry, 8u plus 8u. And let's see, that will leave us with u minus 8. And oh, I've already got a u minus 8 here. So what we're going to do, just to help me with my next step, is I'm going to pull out an understood 1, which doesn't really change anything, but it will help me with my next step. Because the next step, we factor out the common factor, which is the u minus 8. So we factor out the u minus 8, and we've got 8u plus 1, and that all equals 0. And you can go ahead and solve for u if you want to, or you can go ahead and replace it back with what u is actually equal to. It's actually x to the 1/3 power. I'll go ahead and solve for them first, and then we'll replace. And so let's see, I got a little bit more room over here. So on the first one, if I solve for u, that would be u equals 8, right? And if I solve for the second one, I got to subtract by 1 and divide by 8. So that would be that u equals -1/8. Okay, hopefully you're seeing that. So subtract by 1, divide by 8. And so that's what I get for the u's that I solve for. But now we're going to, we're not really solving, we don't, we're not really looking for u. We're really looking for x. So I got to replace these with what that's equivalent to. So it's equivalent to x to the 1/3 equals 8. We'll have x to the 1/3 equals -1/8. And what we're going to do here is I'm going to have to cube both sides to basically right there nullify the 1/3. And so this will become x equals, let's see, that's a big number. Let me 512. And then on the other one, we'll go ahead and cube both sides here. And we're going to get x equals -1/512. Okay, and we should be good on those because we didn't raise both sides to an even power to solve to where that shouldn't cause an issue. If we did, you might want to be a little careful if your answers are correct, but we're okay with that. Okay, so I think this is pretty similar to that one. The numbers are a little bit more friendly, but still probably a little more than we saw in the video notes. So once again, this time I'm just gonna factor it. I'm not gonna do substitution this time. You could if you wanted to. So that tells me that this is gonna be, oh, but see, I got the 3 there. I'm going to do guess and check, by the way, okay? Um, so the way that works is I'm just going to kind of guess and we'll check it at the end and see if it's right. So the reason I'm going to do it on this one is because I know this is going to have to break up into a 3 and a 1. And so really that kind of limits my guessing. So that's why I'm going to do that. And then what I have to figure out now is what multiplies to give me the plus 3, but then the inner and the outer have to add up to that minus 10 x to the 1 half. And so it's going to add negative, and this is a positive, so I'm going to have negative, negative. So this is going to have to be a negative 1 and a negative 3. It's just a matter of where do they go. And so the negative 3 is going to have to go here so I can get that minus 9x to the 1 half. And then the minus 1 will go here and give me a minus 1x to the 1 half. And that would sum together to be a minus 10x to the 1 half. Okay, so then what we'll do here next is we'll take each one of those, set them equal to 0, and solve. So on this first one right here, I would add 1 and then divide by 3. So I'd end up with x to the 1 half equals 1/3. So set it up equal to 0, and I know I'm skipping a couple steps. Hopefully we're good here. And on this one, you would just have to add 3 to both sides. So I'd get x to the 1 half equals 3. And then now what we're going to have to do is square both sides. Now this is the one where you have to be a little bit more careful with your answers. Um, so let's see, when I square power to a power, this just becomes x equals 1/9. And then on this one, when I square both sides, this will become x equals 9. And so you do have to be a little bit more careful on these, but I don't think there's any issues with this problem. They should both work. Where usually there's a problem is when you square both sides and you have a negative, and basically you're squaring out the negative, that usually can cause a bad answer to show up. But I think both of these should be fine. You could always plug them back in just to double check it, but from what I can see, it looks like they both should work. Okay. All right, so I think the next part kind of goes in a different direction, so I'm going to stop this video here and make a second one.